On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at a ladder problem that's involved with related rates. This is a classic Calculus 1 related rates problem. As a matter of fact, we'll see at least an additional example in a future video. A ladder that is 20 feet long is sliding down a vertical wall at a rate of 2 feet per second. How fast is the base of the ladder sliding away from the wall when the base of the ladder is 12 feet from the wall? Now, these ladder problems, you're always going to draw a right triangle for these, and one of our basic formulas is a squared plus b squared equals c squared. A is going to be the distance from the top of the ladder to the ground. That's our A. This is going to be changing because it's sliding down. B is the base. This is the distance from the base of our ladder to the vertical wall. This B is going to be changing because as the ladder slides down, this distance here is going to be getting bigger because the ladder is going to be going this way as the top of the ladder goes down. And C is the length of our ladder. Now let's read this problem a little bit more. The ladder is 20 feet long, so therefore C is equal to 20. That's never going to change. The ladder's length itself is not going to change. It remains constant. Since it remains constant, the rate of change of the length of the ladder, dc dt, the rate of change of the ladder with respect to time is going to be equal to 0. That's going to be useful when we do some differentiation right here in a moment. Now what about this 2 feet per second? The ladder is sliding down a vertical wall at a rate of 2 feet per second. So the ladder is going down. The rate of change of A, because A is this vertical distance from the top of the ladder to the ground, dA dt is going to be equal to a negative 2. Very important to use a negative there because it is sliding down the wall. This length is getting shorter. Now our question says, how fast is the base of the ladder sliding away from the wall when the base of the ladder is 12 feet from the wall? So we're trying to find the rate of change of this distance right here, because here's the base of our ladder. As this slides away, at what rate is it sliding away from this wall? dB dt is what we're looking for. When b equals 12. I'm going to go ahead and do some calculus, and then we're going to come back and see that we need to find some missing pieces before we can actually solve for dB dt when b equals 12. Let's take our Pythagorean theorem equation and let's differentiate all of our variables with respect to time. So right off the bat, we have 2a dA dt. I took the derivative of a squared, which is 2a, and since we are differentiating with respect to time, tack on your dA dt, plus 2b dB dt. Same thing there, differentiating b squared, just like a squared, we tack on our dB dt. And this is going to be equal to 2c dc dt. Now we're trying to find dB dt. This is what we're trying to find right here. To solve for dB dt, we have to have something to plug into A, something to plug into dA dt, something to plug into B, something to plug into C, and something to plug into dc dt. Well, notice we almost have all of that already. We know that C is always going to be 20. We know that dc dt is going to be 0. Well, that's good news. If we take 2 times 20 times 0, we get 0. But we're missing something over here. We have a b. We know b is equal to 12 at a certain instance. We know that dA dt is negative 2, but we don't know what a is. We can solve for a using our original Pythagorean theorem equation. A squared plus b squared, that's going to be 12 squared, is equal to c squared, and c is going to be 20 squared. Let's move the 12 squared over here. Therefore, we have a squared is equal to 400 minus 144 when we subtract that over here, and that's going to give us 256. Taking the square root of both sides and using the positive answer here, we get a equals 16. What this means is this. When the base of the ladder is 12 feet from the wall, the top of the ladder here is going to be 16 feet from the ground. All right, let's plug this into A. Let's plug in our dA dt that we have over here, and let's plug in our B value of 12, and we can solve for dB dt. And that's exactly what I've done here. 2 times A, which is 16, times dA dt. Remember your sign there, that's a negative 2, plus 2 times that B value we were given of 12, times our unknown dB dt is equal to 0. Working this out a little bit further, we have negative 64 plus 24 dB dt. Let's add the 64 to both sides. And then finally, let's divide by 24 to get dB dt by itself. Simplifying this down, we get 8/3 feet per second, which is approximately 2.7 feet per second. Now notice we do have a positive answer here, 2.7 feet per second. And the reason why that's the case, we were trying to find the rate at which the base of this ladder right here, at what rate is it sliding this way? Well, as it slides that way, this distance here is getting bigger, hence we have a positive rate of change here. Whereas we had to be careful at the beginning, since the ladder was sliding down, that rate of change was negative. And there you have it, example 1 of a related rates, a classic ladder problem that's falling down the side of a wall. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.